Hello, do you hear me? Okay, great. So nice that you came for my talk and that you've chosen out of others. Okay, so I'm Jarek, just an architect and engineer, GmbH. I work in Switzerland for various companies, and yeah. So by the way, it's really fun to be closing a Scala conference with a KOTLIN. Just check that this door is open, so you have no chance of catching me if you want to stop me. I am not worried, I am not scared. So, Kotlin in few steps, really. This will not be a lesson about what a Kotlin is. Who has seen Kotlin before? Okay, so you basically know. Who can recognize which part of this is Kotlin? Above or bottom? Which one is Scala, maybe easier? Okay. Really, you see where? Ah, you are programming with colors. Okay, I don't see colors. Okay. But okay, yeah. So basically, as you see, like average developers is no difference, and it's like in this part, like it's really those languages. If you haven't seen, but you majority of you have seen the different. That actually those are languages. You know the Kotlin. So, but they are somehow similar. Yeah. Now there is the differences because there are some differences. Of course, you also know that, and maybe for me the major difference I've realized is basically that where it's about functions. Like whenever you do a function method in Scala, what you see is def. Yeah, and that's like really, I think this scares a lot of developers. Really, sometimes I ask myself, why are people so scared of Scala? One reason is you just play with def, and that's something we mortals are basically afraid of. Well, in Kotlin, in that part, you have only fun. That really explains a lot to me. Maybe it's not something that's not a really wise decision, but maybe unconsciously, like somewhere we take that into consideration. Okay, just my guessing. Of course, you don't have normal fun. You can have some private fun. I haven't, that's obvious, like, yeah. I haven't pictured the public fun, but you can have internal fun just for think it's like, this is like only for modules. So there is some difference in Scala. We can have something for a package, sub-packages. Here it's internal for compilation module, just if you haven't heard. And this is maybe more advanced thing. If you have enough fun, you can suspend it. It's about coroutines, also interesting fact, some more advanced stuff. But about lambdas, of course, Kotlin has lambdas. And they look like this. There is a little difference with Scala, and you see that we use a simple arrow as in Java for lambdas. And this is something I actually like in Kotlin, although sometimes it looks ugly, but it makes life easy that always I have a braces around lambdas. So if something is in braces, this probably is a lambda. This makes the life of a developer quite easy, and actually I kind of like this feature. So this is it. And if you looked at all of that, the first impression, that was my impression like 2 years ago probably, it's like, what's the point? Like these languages are more or less similar. Like, so the point is, what is a Kotlin? It's just Scala minus minus because it's like some feature. That was my first impression. But then I realized it's more like that. It's just Java++. Why? Because that's maybe, if you don't know Kotlin and you have one sentence that I propose about Kotlin, this is Scala-like syntax with just Java type system. That's it, like mostly definition. Of course, there are differences, but mostly one very simple, but this is what Kotlin probably is. And the question that might come to you is, who had created that and what is the reason for that? Yeah, that's why would anyone create Kotlin, yeah? And I think that was mostly like that, like Dmitry Emierov, he was, really? That's something was written in the history of Kotlin that he didn't like the slow Scala compiler, so he decided to write his own. But okay, this story maybe wasn't exactly like that, but there is something in it. So, and yeah, it's really fast if you look at the compilation time. It's one of the strong points of a Kotlin, the fast compilation time. But, so we may think it's just inferior Scala, but it's really more than that. If you just say, oh, Kotlin is not worth anything, just I have way more in, it is just better Java with less boilerplate. No, they have some interesting things. For instance, this one, who has heard about this null safety? Most of you. So I would say this is one of the greatest features of Kotlin, which is so simple. It's a pity we don't have it on, I think, perfectly similar in Scala. So we can always break a code in Scala just assigning null. In Kotlin, we have basically null is forbidden unless you annotate type with this question mark, which says it's nullable. And then you have special even operators. So it's like checked exception in Java or whatever, where compiler takes care and enforces you to check for null if your type is like this. Of course, you don't do that often. And by the way, optional, all that works in Kotlin as well. And I don't use that as often. I use it mostly when I am forced because some library from Java is using nulls or whatever. Then I'm getting into that. It's not that you really use it a lot in Kotlin. You don't have to. And by the way, for instance, this type of length, then it will be like that because with these operators, int as well might not be there because it might be kind of null. But here, very important thing, for instance, if you work with Java, you get a return time from Java. What is this? It is might be nullable, might be not, because Java doesn't really encode that in a bytecode. So there was actually the decision to be made. If we use some value from Java, are we enforced by the compiler to always check for null? That would be really tedious and a lot of work. So they decided to introduce some pseudo-type t exclamation, which basically means one of those two, and it's your developer choice to check for null. So you might check for null, or you might know that actually there will be never null, in fact, and so you don't have to. So it's like, this is a very, this one decision, and everybody that looks into null safety in Kotlin gets to this point and says, oh, why? It would be so beautiful that we have perfect null safety, but then just think about it. Every time you call Java library, which you do a lot in Kotlin, you have to do null check. That would be really tedious, and they decided for pragmatic reasons to not force you to do that, to make your life actually easier and to have less boilerplate in code. So this, I would show this decision, which you might not like, shows that the Kotlin is really pragmatic and has really no point about academic goals or whatever like that. It's just to make you write less code. They have something like extensions functions, and by the way, this is more or less, so for existing type, from any library, from base standard library, you can add additional functions. The same thing we get with Scala, with implicit classes. This is quite the same functionality that we get. It has generics, as in Java, but for instance, what I like, those are really poor generics. It's nothing like we have in Scala, but for instance, they don't use plus, minus, anything like that. They use in and out, which very simply shows you, do you need it as an input, output parameter, so convariant, covariant. This is actually, for each developer, now it's easier than in Java to know, for instance, we now use t as an input part. This is so easy. Often in Scala, I'm really thinking plus, minus, and in the moment I'm thinking plus, minus is not what I have in mind. It's just where it's positioned. So this really makes the life of the developer easy. Some people that are really keen on Scala type system hate this, because this is actually oversimplified. But nevertheless, it's pragmatic and it works. And Java developers love it. So they also have, to some extent, reified generics. So basically, if you have inline function, that is another type of fun you can have in Kotlin. I don't really like it that much, but in some functions, you basically can know at runtime, actually, even what kind of t, or actually in compile time as well, what kind of t you are using. So it's reified generic. It's limited, but it really does the job. For instance, here we know which t actually we are going to read from JSON. That's from JSON with JSON library. So it's practical. Okay. It has some operator overloading and infix as well, infix methods, but very limited. So for instance, you won't spend a week deciding what kind of fancy operator are we going to use with kind of two waves and an arrow, whatever. That's not possible with Kotlin. You can only use like plus, minus, all that standards, and they always map to some predefined name of function. Like plus will always give you to the add. So it means if you work with big decimal, whatever simple classes, it would be easy for you. If you are really like things like they do in, for instance, in Akka streams with all these graph operators, whatever, or in as well partially in Scala Z, sorry, forget about it. You can't have that in Kotlin. Although you can have infix operators, so some of the stuff still may look nice. For instance, we use that in tests. So for instance, X should be something that's actually used. So if you, for instance, know Scala library, Scala test, there is a Kotlin test, which looks very much like the one. OK, so there are a lot of more features, but let's say what is the strength of the Kotlin. And that's really important. So I see this one strength. I'm coding in Kotlin right now almost 2 years, not full 2 years, and before I only knew about this language, I just gave it a try. And I'm quite satisfied, so it's really pragmatic. You see that. You might not like it, but it's there. It's really, from a developer perspective, you see that they basically choose the things for you to make the life easy and compilation fast, of course. And immutability, it has the most, for me, important thing. It favors immutability. So vals, as you've seen, they don't have case classes, but data classes, which are totally like case classes. And this is something that you might not see but all the things like if, while, for, those are expressions. So basically, you can use it as Scala as expressions. So you can build basically almost functional programming with that. You can do that. That's for me the most important part about doing functional programming without type system part. But this is already good enough for most business things I'm doing. And this is also cool. Java developers quickly learn that stuff as well. So for instance, you can do that, all of that in Java, but without having expressions, with problematic immutability in Java. It's just too much work, and people don't do that. After they switch to Kotlin, they instantly start to be more immutable, which is cool. And of course, they have functions, lambdas, even support tilrec. I don't even remember if I've ever used that in Kotlin. So it's like a keyword, like a notation in Scala mostly works the same. It's, as far as I remember, it's a little bit more limited, but I haven't seen this limitation. So it's only there. So what is cool? In Scala, basically, we don't have any problem using any Java library, but vice versa, it's of course a problem when we create something in Scala, making that usable in Java is additional effort, sometimes really horrible. So in Kotlin, it's actually hard to make something not Java compatible. So if you're mixing a Java and Kotlin code in one project is actually de facto standard. It's easy. You can do that. And you can even, IntelliJ as a tool, for instance, makes it for that you copy a Java code into Kotlin class, a Kotlin file, and it's automatically even converted, which is awesome. It works. And you have it, of course, important part is with that I've seen later that why maybe Java developers like Kotlin that much, because they are not forced to learn any new tools like SBT, whatever. They just stay with old good Maven, which works for that quite well, as Gradle. And so they don't have to do two big steps while introducing Kotlin. Compiler is fast, which is also like this is a part of the design of the language, and yeah, that's really important point. The tools, ID and JetBrains, that's a huge vendor behind. They really do their job well. So tooling for Kotlin in IntelliJ is great. It's not only just the tools that you use. Like all this refactoring and just jumping around the code. Even things like Kotlin Cones course that you can take in IntelliJ, so you can solve the puzzles in Kotlin. This is all makes jump into Kotlin way, way faster for a typical developer. Also, the thing that actually I haven't really tried, apart from some Hello World, Kotlin.js. Almost from the beginning, Kotlin was designed as a multi-platform language, which is important because it means we might have Kotlin on JVM, on JavaScript, and also native. And this is more or less like in Scala, but in Scala it wasn't really by design like that. We have actually Scala.js. I do recommend. I was talking about it like a year or two ago. I really use it in production. It's really cool. I'm actually surprised how good it is. With Kotlin.js, I've heard different opinions, but please check on your own. At least it's supposed to be working good. Just this thing. And also Kotlin native, I know it's not really great at the moment, but they are working on that. And Important part, of course, libraries. So we do have all the Java libraries, of course, but now we have as well Kotlin-specific libraries which use Kotlin syntax, and it's you will see some examples later. And there is a library called Wave. Who knows this library? Okay, so for those that don't know, if you know Scala collections, this is basically port of Scala collections. Actually, it's not done for Scala, it was done for Java, so immutable collections, and you probably know all these names, and really you will find there everything, the implementations are similar, and it works perfect with Kotlin, actually better than with Java because of this immutability that is it's more friendly in the language. And there is also some small wrapper library for that makes that uses Kotlin syntax, so basically adds some more sugar. That it's not really needed, but it's more fun with that. So strong thing about Kotlin, I was actually surprised how fast Java developers start with Kotlin. Really, I tell it's 15 minutes. Really, you don't have, really, you just start and you do. There are so, of course, the language actually, you can learn that probably it takes a month to learn advanced features, but really from the moment zero, you just do it and it works somehow. And to the point that now, my colleague, for instance, writing Java, he's using, this is cool, there's a plugin in IntelliJ that shows you Java code as Kotlin instantly, which I can't really get to, for me it's hard to work with that, but people like it, it seems, and more people are using that. So I would say that if you are experienced Scala developer, you can start using Kotlin. I mean start in 10 minutes, so obviously you see 5-minute advantage. It's there. Like, yeah, you can, but actually you have a lot of advantages there. So why is Kotlin so popular? Of course, if you are doing something for Android right now, it's really hard to not work with Kotlin. You know that, and that's easy point. But actually, it's not. Most people think that's really the point. But if you are not into Java backends, you might have not heard about this. Like Spring, you know, the major framework for Java backends, yeah, annotations, reflection, magic, all that stuff. But actually, for the last version, they support Kotlin as like prime. Okay, let's one of two languages. They say Java as well as Kotlin. This is really important. Their support is really a big name in Java community, and as well as Spring Boot, and even more. They go farther, because actually they started, and that's the thing I'm using. Spring is now a little bit better Spring than before. They added functional part to that. It means I do have running services with Spring which don't do any runtime reflection, any class path scanning, and things like that. Basically, they look like services written with HTTP or similar stuff that you know. And this is, for instance, the syntax for even the newest project, Spring Kofu, which basically is just functional API for defining REST endpoints. This is in the current Spring that's official product, it's almost like that, but in the new Spring that's coming, maybe it's like the experiment project called Spring Fu, and they have Spring Kofu for Kotlin. That's even better. So that looks nice, really. Main method as humans would do, and then we start our REST server. That's so cool. No annotation, no class path scanning, no beans. Actually, you don't have to use them. That's cool. Okay, and also a good name, John the Ghost supports Kotlin. Yeah. So if you don't believe, just listen to this famous video. If you haven't seen, this is really awesome. Really, I would say everybody from Scala community should listen to this from last year's Scala panel, really. But I think it's hard to miss this one. And he said this, like, goodbye, all programmers. I hope you like Kotlin, yeah? That's, of course, well, John, when I told him about this, just commented it like that. Yeah, that I taken his word out of context and since that. But okay, okay. So yeah, that's he might not like Kotlin that much, really, but I am a journalist right now. Okay, he said that he doesn't really, but okay, he doesn't really like Kotlin. So nevertheless, he's still recommending it for all programmers. I completely understand that. That's my talk about. Yeah. So, but of course, you do Kotlin, so you not only have fun. Yeah. Sorry for that. So I am doing a little Scala, like 10% of my job, and in the past I was coding couple of months with Scala as my hobby projects. I mostly use Scala, and most of you, if you are Scala developers, will be sometimes angry at Kotlin. The points where you are angry, for instance, for me, this is, I have some projects with reactive programming, with monads. It's not really anything sophisticated, but still, if you have to put this flat mat everywhere, you are missing for comprehension. This is one of the biggest points, and you see that code instantly is ugly. Like do notation, something would be nice to have in Kotlin. And there were some trials, and I even know some solutions, but none of them is really, I would call cool and good enough. Just language doesn't have anything. So you don't have basically type classes, yeah. You don't have implicits, anything really similar. So I've shown you extension functions, but they only solve one of the problems that can be solved with implicits. This is a very limited thing. Pattern matching in Kotlin, it works. It's actually, of course, better than switch in Java, but it's just switch on steroids. It's nothing like pattern matching you can have in Scala or Haskell, whatever. Yeah. Type aliases, one of the really small things that are cool in Scala. You don't really start to see how good they are when you are missing them in Java. And in Kotlin, I've instantly seen, oh, there are type aliases. But then I realized only global with very limited functionality. No, this is nothing like type aliases, whatever we have in Scala. And now that's the point, that Kotlin is still Java type system with this extension for nil safety, but it's nothing like Scala, not even close, and won't be. So basically, whenever you try to do something more complex, yeah, then it's like, oh, no, Kotlin, no, decision is no, you don't have it. And you will be sometimes a little bit angry, but there are solutions for that, like this. So if you are interested, whenever you would like to do something with functional programming, with category theory thinking, there is a library called ROKT, and it's really, if you see Scala Z, Scala Z, it's really similar to this story. They basically are pushing the limits of the language, and it's really interesting observation. So remember that actually we don't have type classes in Scala. We just can do them with implicits, but there is no language doesn't have official, let's say, type class. Yeah? So they tried the same approach with Kotlin, and they simulated type classes with approach. I don't have that much time to describe this, but you see, basically, we create companion object. Then we can have then we define operations like empty, because we are going to create a monoid for something, like monoid type class, like monoid instance actually. Because the type class is already defined, then we create empty, then we create combine operation. It's really, there are no code generation is involved, nothing really special. This is just Kotlin, and then we can finally call it we can say this is like saying the instance, monoid instance for person is like that. So we just basically instantiate type class, prepare here, and then we can call it, you see, like combining the persons with this, thinking of it as a monoid, and then we have like our result. Of course, here is no brainer. This is a very simple example, but it basically works like that. So, and actually this ROKT tries to support all of the things you would imagine. Some of them, like optics, and as far as I know, monad transformers, actually they do need at the moment code generation, so it's not really all that possible inside of Kotlin, so it's not really clean. And Kotlin doesn't have anything like macros, so yeah, this is real code generation involved, that you see this code somewhere. So not beautiful, but they're working on that to make it better. And so what basically this Kotlin means for Scala? That is a very important question. Yeah? This is a competition. This is really competition. Everyone doing just thinking of better Java in a business has this better Java. But one thing, I do remember this year, I'm not sure if it was 2001, 2000, when C# came with Microsoft .NET. And we in Java were angry. They just copied our language. And they did a really nasty copy, and they even claim it's better. This is a just competition. We're afraid what will happen, actually, because Microsoft had way more money than Sun at that time. But actually, it appeared for our developers this competition was good. Only, I would say, mostly because of C#, Java really evolved. At that time, in year 2000, Java didn't have generics. And if you try one day writing this Java code, you would be like surprised, how could anyone use this language? I was using that. It was really popular language at the time without generics, and no one needed them. Really, only competition from C#, because, by the way, Java had generics faster, but C# was just only announcing that they will do those generics. And this made generics faster in Java. So the story is more complicated, but basically they are still forcing Java to evolve. Competition from .NET. So competition is actually good. So this might force, let's say, Scala community to deliver things better as well. So one thing, of course, Scala at the beginning was just a better Java. You might not remember that was like the selling point at the beginning. But really, if you were looking for better Java, Kotlin is better Java. Simple like that. So this is just strong OOP with some FP, enough for most of the industry. So what is the future of Scala like at the moment? You have competition from Kotlin. You have real competition from Haskell. Even, for instance, I'm partially involved a little bit, only just fixing sometimes some things in ITA. So basically, Haskell on JVM. Wow. Then comes Scala 3, which is actually different Scala. So who is going to use the latest Scala right now when new Scala will be better and a little bit different? And last but not least, community is different. You know, you have to do something if you care about future of Scala. But I think competition really enforces that people see the danger and maybe the Scala community will do something. But it's already fighting back. I see that because what we have, this wave. I think Scala people disgusted by seeing how Java collections work. They created this wave, which is kind of a copy, but it's really cool. So you just go there to this world, enter, and you use the same terms as before. It's good enough. ROKT, the same. And basically for most of the libraries you know and you use every day in Scala, as long as they are not really strong FP with type category, you would have some corresponding libraries in Kotlin, like Kotlin Ktor library for HTTP, etc. So they are there, and as a Scala developer, you will know how it looks like. Maybe it went like this. If Scala doesn't evolve, maybe Kotlin will evolve, and we'll have Skotlin. And by the way, for instance, there is this from the creator of ROKT. You see, 666 people support it. So, and this number stays like that. I don't know for which reason, but Kotlin has this keep list, the pull requests that might get to the language, and this is one of the discussed. So you can actually increase this number and make creators of Kotlin thinking that more people will need that. Yeah, it's actually waiting more than a year there on the list. So Kotlin I see as just real next chance to bring FP to the mainstream. It's already happening, I would say, really. So I'm basically about to end this, and my message for you, actually really future of Scala is not clear, but you are not Scala, you are developers. You are pushing the world, you are changing. You need tools. Kotlin is a tool you might use, and you might have some fun with it. I've shown you. So you can, with that, you can easier than in Scala show the power of FP to Java developers. I already seen that. So maybe they will make those first steps, and then they will need some more steps. That's the easier way than Scala, I would say. You can take Vavr in your backpack. This works already. Or probably ROKT. I have never tried this. But maybe there will be a day then the Java developers will see, oh, we need that. Maybe. If you need that, and you are forced to do Kotlin, might be that it will be something you have. And remember, don't forget that you have this 5-minute advantage over regular Java developer, which is like you can take one more beer or whatever. So thank you. And if you have questions, I am ready for questions. All right.